Okay. Now, suppose we are given the vector A in this direction, and the vector B is this one. Then look at the right angle, PRS here. The red vector here is the projection of the vector B on the vector A. So, okay, that's just a definition. And you see that if vector A and vector B are at the same direction, the general direction, then the cosine, the angle here, theta, will be smaller than pi over 2, right? Or if the angle theta between vector A and vector B here is larger than pi over 2, then the projection of vector B on A is pointing in the opposite direction of vector A. But yes, here, like this, okay? Okay, now Pythagorean theorem. Look at this triangle. If theta is this angle, what is cosine of theta? Let us call this, the red one here, is, this is here, right? Projection of A on B. Then cosine will be the magnitude of this projection vector divided by the magnitude of vector B here, right? You all see it? And here, this term, the magnitude of this projection vector, we call it the scalar projection of the vector B on the vector A, okay? Just definition. Then, how to compute if vector B is given? Can we find the magnitude of vector B here? Yeah, it's easy, right? Square root of B1 plus square plus B2 square plus B3 square. And if vector A and vector B is given, can we compute the cosine angle here? We can. So therefore, we can compute the scalar projection of vector B on A easily using this relation, okay? Okay, observe that dot product of vector A and vector B will be the magnitude of A times magnitude of B cosine angle. And here, this is the projection, right? Scalar projection. Therefore, if we divide both sides by the magnitude of A, we have this relation. Do you agree? This equation. But look at this. What is this guy? Yes, thank you, Aluk. This is the unit vector in the direction of vector A. Do you all see it? That vector divided by its magnitude. Therefore, in the future, it's easy to compute the scalar projection, right? Just take that vector, take a dot product of that vector with the unit direction of a vector A. That's it. Okay? That is the scalar projection of vector B on A. And so this is scalar projection. And the vector projection, if here, if it is here, then what is this vector? we can simply, this is the scalar projection of vector B on A, right? And what is this guy? The one in yellow here. A divided by magnitude of A. That is E, the unit vector of the vector A, right? So therefore, the vector projection of a vector B is easy. We just find the scalar projection and then multiply with the unit vector of vector A. Easy, right? Okay. Then that's it. That is the idea of vector projection of n scalar projection. That's it. Quite simple. And now let us together do the example here. If we are given the vector B like this and vector A is like this. So what is the scalar projection of B on A? So it's easy, right? Let us call it projection of B on A here. It will be the vector B times the unit vector of the vector A, right? Okay. Is a formula. Then we also know that unit vector of this guy will be the vector A divided by the magnitude of vector A here. Okay. Then we can do everything at the same times here, or it is vector B times vector A divided by the magnitude of the vector A. Okay. Now, what is B? 1, 1, 2, right? So it is here. It will be 1, 1, 2, dot, negative 2, 3, 1. And what is the magnitude of A?
Square root of 14.
Wow, very good. Let us do it slowly. Negative 2 squared plus 3 squared plus 1 squared, right? Then just do it, okay? The dot product of this guy will be thank you, Aluk. 1 here, right? And divided by 14, very good. Square root of 14. And finally, it will be negative 2. And here plus 2 will cancel each other. It will be 3 square root of 14, right? Very good. That's it, right? It's not difficult. The scalar projection. Okay. Just use that formula. And now the vector projection of this guy. it will be, let us call it the vector L, or yeah, projection of B on the vector A. It will be the magnitude of this, right? Multiply with right, the unit vector of A. Okay. Then, what is it? The projection, the scalar projection of this will be 3 square root of 14. We just found it here. Okay. Multiply with the vector A, which is very good. The magnitude of this guy will be square root of 14, right? Okay. This is simply a product of a scalar and a vector. So it will be 3, 14, very good. -2, 3, and 1, right? In the exams, you can stop here, right? Or we can simplify it further. The product of a scalar and a vector, it would be that scalar multiplied with all components of that vector, which means it would be the same as 3 times -2 divided by 14. The second term, what is it? Thank you. And the last one? Very good. So therefore, we can simplify this guy, right? It would be -3. Very good. It would be 9/14. We cannot simplify this guy. Yes. Oh, there's a number 3 here. Very good. Thank you. Okay, that's it. Are we clear? Is there any question? Very well. Then here in physics, there are some application. Suppose the work done by force F. So we apply force F here to an object, and the object moves from the position P to Q, and this distance we call it displacement. Okay, and the angle between the force we apply here and the direction of movement will be theta. Then the work done will be the force, which is the red vector here, right? Multiply with the displacement, is from physics. And the red vector here is a projection of F on the direction PQ here, right? Which is the magnitude of F times cosine theta here, okay? Times the distance from P to Q, which is the magnitude of D, if D is the vector PQ here, displacement vector. We rearrange this term, right? And this is nothing else but the dot product of F and D, where F is the force we applied and D is the direction of movement. Okay. Does it? So, an example here. If we walk in this pool, a distance about 100 meters, meters, yeah, along the horizontal path by a constant force F here, the handle of the wagon is held at the angle 35 here, above the horizontal. So the question is, find the work done by force here. From the previous argument, we know that the work done by this force would be the dot product of F and D, right? And it will be the magnitude of F times the magnitude of D times the cosine angle between them. Therefore, what are they? Very good. Times cosine of 35 degrees, right? Does it? So use your calculator to compute this and find the answer. So that is all about the section 12.3. These are not difficult, just memorize, try to memorize these. So today, okay, let us take a look at the daily schedule. Today we will study the section 7.8. We are behind our schedule a little bit, but it will be fine. We do slow but steady. Slowly, steadily. So let us do the section 78. The homework is explained. 12.3 will be due this Friday, not today. Okay. And today we'll do 7.8. Okay.